Always on Saturday?
In section 8.7, we're going to learn how to calculate formulas from experimental data. There are different kinds of formulas. An empirical formula is one that gives us the simplest whole number ratio of the atoms present in the compound. The word empirical means from experiment. So on Friday in lab, we took magnesium and we burned it in a crucible, combined it with oxygen, and weighed the product, and we're not able to calculate the empirical formula because we hadn't talked about this yet. So we're going to learn how to do that today. We can calculate an empirical formula from either the percent composition of the compound or from the masses of each element. And in the experiment we did, we have masses of each element. So the empirical formula is the simplest ratio. The molecular formula is the actual number. It's the actual formula of the compound. So for this compound, C6H6, which happens to be named benzene, each molecule has 6 carbon atoms and 6 hydrogen atoms. So that's the molecular formula. But the ratio of 6 to 6 is not the lowest whole number ratio. 6 to 6 is like a fraction that could be reduced. So 6 over 6 could be reduced to 1 over 1, right? That's the lowest fraction, 1 to 1. And so the empirical formula is going to be CH. For every carbon atom, there's 1 hydrogen atom. This doesn't tell us how many carbon atoms are in a molecule, but it gives us the ratio. The empirical formula can be found from experiment. The molecular formula cannot be found directly from an experiment like what we did. There's a relationship between the empirical and the molecular formula. The molecular formula is some multiple of the empirical formula. So just like we take 1 over 1, 6 over 6 is a multiple of that fraction. So if we multiply this by 6, we get 6 over 6. Here, if we take this empirical formula and multiply it by an integer, we get the molecular formula C6H6. Now, how do you know what the integer is? Well, that's a different question. But do you see that the molecular formula is a multiple of the empirical formula? It could be a multiple, it could be 2, it could be 3, it could be 1. Sometimes the empirical formula is the same as the molecular formula. I think there's some examples coming up. So look at these and let's determine the empirical formula for each of these. These are molecular formulas. So for H2O2, what is the lowest ratio of hydrogens to oxygens? HO. So in an actual molecule, this is hydrogen peroxide. In an actual molecule, there's 2 hydrogen atoms and 2 oxygen atoms. That's the actual molecular formula. But the empirical formula is the lowest ratio, which is HO. How about C2H6? CH3. Because we don't write 1, so it is C1. It's 1 to 3. So CH3. It doesn't give us the actual number of atoms in the molecule, but it gives us the ratio. How about CCl4?
That's what it is.
It's the same. It's carbon tetrachloride. There's a ratio of 1 carbon to 4 chlorines. And there happens to be 1 carbon atom and 4 chlorine atoms in a molecule. So for letter C, the empirical formula and the molecular formula are the same. Any questions?